All right, so today what we're going to do is we're going to look at chapter 16, which is all about algebraic equations. And we're going to define that in a minute in a way that'll help you understand what's going on. But before we do that, what I want to remind you of is the idea of terms. We talked about this before when we introduced the algebraic system. Remember that all terms have exactly 4 parts. The first part of every term is its sign, and the sign is going to become so important to you now. So you make sure that you don't think of those pluses and minuses as add and subtract. Think of them as the sign of the term, because it's going to tell you what to do in this case. Second part is the coefficient, and remember that coefficient is just a fancy word for the number part when you're talking about a term. Coefficient literally means multiplier, right? But the multiplier of a term is its number. And then you have the base, and the base of an algebraic term is its variable or variables. It can have more than one, remember. It can be more than one letter. But for what we're working on, you're only going to have one letter. So the X, the Y, A, B, C. Again, it doesn't matter what letter you have. And then on every base or variable, whether you see it or not, there is an exponent. Now, you're not going to be working with exponents in this particular case, but when you learn something, if you learn all of it, then when it does happen, you won't be surprised, right? So adding one more layer on it, you're used to exponents and working with them, so it's not going to make any difference. Now, I want to talk a little bit about the variable. Remember that the variables are simply those letters, and they mean some unknown number. Or you can think of it as what number. It doesn't really matter how you think of it, but what you know is that letter represents some number. We just don't know what it is, right? Now, in past exercises, what we did was they told you that x was -5. So you put a -5 in place of your x and you did the math, right? Or they told you that y is 2. So you put a 2 in place of the y and you did the math. But for equations, what's going to happen is they're not going to tell you what number that letter is standing in for. Instead, we're going to use some basic arithmetic, and that's all it is, arithmetic. Arithmetic means what? Add, subtract, multiply, divide. That's all you're going to do, so don't get creative. Algebra is not hard, as long as you really, really think about the pieces, okay? So we're just going to use some basic arithmetic to move things around so that we can find out what number, okay? And what I want to do first of all, though, is I want to talk about how you can identify something as an equation. We know that it's an equation simply because it has an equal symbol. And you can call it equal sign if you want. It's really a symbol. Most books call it equal sign too. Signs are positives and negatives, right? But a symbol, the mathematical symbols are what we're talking about. So it has that equals, okay? And that's how you know it's an equation. And you don't need to know any more about it than that. It's an equation because it has a what? Equal symbol. It's just that easy, okay? So therefore, if it doesn't have an equal symbol, then it's not an equation, right? And we haven't worked with equations yet. We haven't had any of these. All we've had are what are called expressions. An expression is just a collection of terms. But an equation is a collection of terms including an equal symbol. Okay? Now, are all terms algebraic? No, it's only algebraic if it has a letter in it. You could also have what are called number terms. And number terms really do have all 4 parts, but I'm not going to blow your mind with that right now. We're just going to move on and say number terms just have signs and numbers. They don't have the variable in them that turns them into algebraic terms. One day I'll show you what it really looks like, though. Okay?
Does that mean you're going to get
All right, so what I want to do first is I want to write down an equation that you could solve in your sleep. It's so easy, okay? So say, for example, you have 3 plus some number equals 5. Now, what number would you add to a 3 to turn it into a 5? A 2, right? Okay? All right? So, anyway, all right, now. So you can see that some equations, you can just look at it and you can see what number you should be replacing it with. But that's not always the case. They get a little more complicated, and so you want to have a process for solving them. Okay? And I'm going to give you all of the steps that you're going to need to know, you're going to need to have to solve any equation. And then we're going to start with simple ones, and then we're going to build. So you won't use every step every time. But think about it like this. If you're going to go somewhere, it's just as important when you're walking along not to turn on the wrong street as it is to turn on the right street, right? So you need to get in the habit of asking yourself every question every time. I don't think that it's a good way to learn a process by telling you, okay, turn right on the next step. Now you know how to turn right, right? I want to put it all together so you get used to practicing every step, because you literally need to memorize it. If you have these steps memorized, you can solve any equation. So easy. Okay? So the first thing we want to do is we want to talk about the goal. What does it mean to solve an equation? What's the point? Okay? Yeah, we want to find out. Yeah. Our goal is to get the variable. Now notice it doesn't say variable term. It says variable. Okay? To get the variable completely by itself. We want that variable to be on one side of the equation. And now it doesn't matter which side of the equal symbol it's on. It can be on the right, it can be on the left. Typically, teachers like for it to be on the left because it makes it easier for us to grade. But who cares? Right or left, it doesn't make any difference. If x equals 2, then 2 also equals x. Does that make sense? Okay? So it doesn't matter which side it is. Just has to be completely by itself. So let me just throw out some scenarios for you. Would I be done if it said 3x equals something? No, because that 3 is still there. I need it to just say x equals something. Would it be done if it said negative x equals something? Nope. I can't have anything with it. Not even a sign. Nothing. Okay? Right? That x has to be completely by itself. Now, the method. And it's just this easy. All you're going to do is use the opposite operation. So, just going to use the opposite operation. So what that means is that if two things are connected by multiplication, you would take them apart by using the opposite. What's the opposite of multiply? Divide, division, yeah. If two things are connected with division, you would, if they're connected with a plus or a positive, you would subtract. If it's a minus, you would add. And now you know how to solve an equation. Now, however, okay, remember that mathematics has to be done in a certain order. What's the order of operations? But remember, the order of operations is what we use when we're putting things together. Our goal in an equation is to move things around, to take them apart. We're doing the opposite. So what we're going to do is, we're going to do the order of operations, but we're going to do it backwards. We're going to start at the bottom and move up, right, with the four basic operations. Now, you're still going to deal with brackets first. You always do. That's not about solving an equation, and we'll talk about that. That's about cleaning the equation up. Think about it. If you walk into your room and you're looking for something, if everything you own is thrown on the floor, it'll be a lot harder to find it than if it's put away where it's supposed to be, right? Yep. So the same is true of equations. If you clean up the equation and get it ready to solve, then you've gotten rid of everything you don't need, and all you need to do then is concentrate on what you do need. Okay? So we'll talk about that in just a moment, how to clean it up. So, what's our goal, guys?
Get the variable completely by itself.
Completely by itself. Good. And what's the method? Opposite operation. Okay? And if you can do that, you can solve any equation. Okay, so let's talk about some of the steps. The first thing you need to do is clean up the equation. Now, there are several steps for cleaning up the equation. Nothing is new. We've done all of this before, right? But it's going to look different in one instance anyway. Okay? All right, so we're going to clean up the equation. So when you're cleaning up the equation, the first thing you're going to do is you're going to get rid of any brackets. Anytime you're dealing with anything in mathematics, brackets are always first. Now, the book is going to show you some shortcuts, and other teachers are going to show you some shortcuts. And they do work when the equations are small. I'll show it to you myself. However, it doesn't always work. A shortcut is only good if you could recognize when to use it. Would you rather have one method that works for everything, or 50 different shortcuts that you have to decide which one works and which one doesn't? 50. Okay, good for you. All right. Well, I'm thinking one method works better for me, but that's it. So you're going to get rid of brackets. Remember that when you're getting rid of brackets, how many steps are there? 3. Where do you look first? Inside. What do you look for next? Exponent. And then finally you look for the coefficient or multiplier. So remember that. Inside. Exponent. Coefficient. Once you learn the process, it never, ever changes. Okay? So that's why it's so important to learn them properly and not to learn a bunch of shortcuts. Okay? Now, next thing you're going to do, after you get rid of any brackets, you're going to clear the fractions. Now, we're going to spend a good deal of time clearing fractions, but we already know how to get rid of a fraction. Because it's an equation, we can do anything we want to as long as we do it equally. Okay? And I'll write that down in a minute. We'll talk about this in a second when we start to solve it. But when I'm clearing the fractions, what does the fraction bar actually indicate? What operation? Division. And what is the opposite of division? Multiplication. So we're going to use multiplication to get rid of that division. Well, and so what we're going to do is we're going to multiply every term by the LCD. LCD means least common denominator, because you may only have one fraction. Well, if you only have one fraction, then whatever number you have, whatever denominator you have is the LCD. But you could have two fractions, in which case you need to eliminate both of them. And if you get the LCD, you can eliminate both of them at the same time. But notice it says every term. So not just the ones that have fractions in them, but every term. So what is the opposite of a fraction?
Multiplication.
Multiplication, because the fraction means to divide, and we'll multiply by what number? The LCD.
LCD.
Right. And you'll see this in action as we go. All right. Next step is to combine any like terms that are on the same side. So you're going to combine any like terms that are on the same side. So we're not moving anything across the equal symbol here. We're going to look on the left side of the equal symbol and see if there are any like terms on that side. And then we'll go to the right side and see if there are any like terms on that side. And if there are, we can combine them. So there may be two number terms on the left side. Well, I don't want two number terms when I can combine them and make one. There might be an x and a 3x. I can combine those into a 4x, right? So combining like terms. Remember, like terms are terms that have exactly the same base and exponent. So x's are like terms with other what? X's. Numbers are like terms to other numbers. Y's are like terms to other y's, right? So you're just going to combine the like terms. So on the same side means on the equal across equals. So you'll look on this side and then you'll look on that side. The equal symbol is kind of like a wall that separates your equation. Okay? All right. So you're going to clean up the equation using those three steps. Brackets, fractions, like terms that are on the same side. Be careful. Don't just think of it as combined like terms. It has to be combined like terms that are on the same side. Because you may have like terms, but they're on opposite sides. That's not combining. That's going to be moving. And if we're moving across the equal symbol, that's completely different. Next, I need a big global goal here. You can do anything to an equation as long as you do it equally. It's a terrible cue. Okay. So, you can do anything to an equation as long as you do it equally. So, could I multiply one side by 9? Yes. As long as I multiply the other side by 9. Exactly the same thing. Could I subtract 5 from one side? Yeah. As long as I subtract 5 from the other side. Say the same thing. Could I multiply one side by 9? No, I already did that one, didn't I? Okay, never mind. My little mind. Okay. Could I divide one side by 7? As long as what? As long as I divide the other side by 7 as well. Could I subtract 3 from one side? Yes, as long as I subtract 3 from the other side. Whatever you do to one side, you must do exactly the same thing to the other. So you can never add 2 on this side and subtract 2 on that side. Be careful. It's a common mistake that students make. Don't do it. Okay. So to solve the equation. All right. So to solve the equation. So far, all we've done is we've looked at steps for cleaning up the equation. Getting rid of the stuff we don't need. And now we're ready to solve it. To solve the equation. Step 1. Now this is step 1 again because now we're talking about solving, not cleaning. Right? It's 2 different things. First step is to get all number terms on one side. Now, books and teachers, again, like to tell you that you want their number terms on the right and your letters on the left. It makes no difference. You can put them either way. And I'm going to tell you how you make the decision in a bit. Okay? All right. Hold on. Scratch that. I'm such a ding-dong. Variable terms. I want to move variable terms. All right? A variable term is any term that has a what in it?
Number. Letter.
A letter. right? It can be an X, a Y, A, B, who cares? Any term that has a letter in it is a variable term. And you want to get any of those onto one side. Now again, it doesn't matter which side, okay? But we like for things, and you'll look at this, we like to keep things positive, so we generally move the smaller one. Because if you move the smaller one, you usually keep it positive. But it doesn't matter. If you think it's going to confuse you, just move them always to the left or always to the right. But you should get in the habit of being able to decide which would be the best for you. The only reason you move the smaller one is we like to work with positive numbers instead of negative numbers, because we don't like to make sign errors. So, and if you move the smaller one, it'll always keep it positive. Okay? Now again, and you're going to move something by doing the opposite. And signs are connected to each other terms are connected to each other by signs. So those pluses and minuses. So if it's a minus, you would add it to move it. And if it's a positive, you would subtract it. But remember, whatever you do to one side, you must do what? Exactly the same thing to the other. Good. Second, get all number terms on the other side. In other words, your variable terms are the most important ones, clearly. Your variable terms are the most important ones. So they're going to tell everything else what to do. So if your variable terms move to the left, where do your numbers need to go? To the right. If your variable terms go to the right, where do your numbers need to go? To the left. Just the opposite side. And again, a number term is any term that does not have a what in it? A letter, a variable. Right. So like -7 is a number term. Is 2y a number term? No. Nope, that's a variable term, right? So keep it that's why we learned about those before. And third and last step is to simply divide both sides by the coefficient of the variable term. So, both sides by the coefficient of the variable term. And remember, the coefficient of the variable term means the number in front, right? And since the coefficient is a multiplier, that's why we're using division to get rid of it. So if it has 2x, that literally means 2 times x. So the opposite of multiply by 2 is to divide by 2, right? So that's what we're doing. We're simply doing the opposite operation in all of these, okay? Right? But we're keeping it very focused. All right? And once you've done that, your variable is going to be on one side completely by itself, and the equation is solved.